due to the increasing amount of debris in space, launching spacecrafts may become unsafe in the future. The U.S. Space Surveillance Network, a department that tracks debris floating through space and reports to NASA, observes over 13,000 man-made objects orbiting Earth larger than 4 inches in diameter. That number has only been increasing, up from 9,000 objects in the year 2000. The organization estimates there are also millions of much smaller objects floating around, and all of it combined weighs about 5,500 tons. Although it's hard to believe, many of these objects travel around the Earth at speeds more than 22,000 miles per hour. Anything traveling at that velocity this high would cause a considerable amount of damage to a spacecraft if a direct hit occurred. Even a tiny fleck of plane traveling at such a speed is capable of boring a quarter-inch hole into the window of a spacecraft. Because there are so many objects flying around up there, there's a concern that collisions between debris will only produce more fragments. Although the probability of collision with a piece of orbital space debris is currently very low, it will not remain so forever. Even if we stopped launching spacecrafts right now and didn't send a single object into orbit, the amount of debris in space would remain constant until 2055. The reason for that is that collisions between objects in space will slowly but surely increase the number of dangerous debris fragments. These in turn will produce more debris and so on in a chain reaction. In a few hundred years, the amount of debris will be so great that space operations will be severely limited, since the amount of debris already up there would be inevitable. Experts are worried this is already happening. The most recent case of such a collision, for instance, happened on January 17, 2005, when a piece of debris from an exploded Chinese rocket smashed into a 31-year-old American rocket that had been left alone. The collision only produced 4 pieces of debris, but observers fear it's only a matter of time before such pieces create an unstoppable chain reaction.
Removing or decreasing the amount of debris in space would also be useful in long-term space travel. With the removal of space debris, the chances of space travel being nullified are slim. This is because there will be less of a risk that space debris will interfere with space travel. Sadly, it is quite difficult to reduce the amount of debris in space, but solutions are currently being developed. There is currently no agency involved in the active removal of existing space debris from orbit. However, an Australian firm based in Canberra has been given a federal government research grant to investigate laser removal of space debris. A number of solutions can be proposed to this problem. Objects in low-altitude orbits below 500 kilometers are affected by atmospheric drag. This lowers their orbit until they re-enter the atmosphere and are thus naturally removed from the orbit. The lower the orbit, the faster it decays. Space tugs could be employed to catch large space debris and lower their orbits for natural decay, or bring them back to Earth. Giant sponge-like objects can be deployed to catch or soak up small debris pieces. After a time, the sponge can be removed from orbit. Attach tails or tethers to large pieces of debris and to increase the drag they experience and lower their orbits. Use large ground-based lasers to push small pieces out of debris into lower orbits. All these schemes will be very expensive and use technology that is still to be developed. The laser scheme looks like it might be the most promising, however political problems might outweigh technical problems.
If we continue on our unsustainable path to launch rockets into space without any way of disposing of them, eventually, man-made satellites will be at a higher risk to get hit by something. When launching rockets into space, it can greatly increase space debris if it's not properly disposed of, which can pose a serious threat to man-made satellites. There are over 20,000 pieces of debris larger than a softball orbiting the Earth at this moment. A relatively small piece of orbital debris is able to cause some serious damage to a satellite, making it non-functional or even causing it to explode, which would contribute to the ever-increasing amount of space debris. Astronomers worry that if we continue on this unsustainable path to launch rockets into space without disposing of them, there'd be a greater chance that a satellite in space could suffer from a collision. At the present time, only a handful of dangerous collisions with artificial space debris are known to have occurred. However, the production of this type of debris is increasing at such a rate that it gives concern for the future. Some cases of satellites being affected by space debris are: in 1996, a French satellite was hit and damaged by a debris from French rockets that had exploded a decade earlier. On February 10, 2009, a dysfunctional Russian satellite collided with and destroyed a functioning US Iridium commercial satellite. The collision added over 2,000 pieces of debris to the inventory of space junk. China's 2007 anti-satellite test, which used the missile to destroy an old weather satellite, added over 3,000 pieces of debris to the growing problem. In the future of scientific endeavor, space travel could potentially be a large part of researching our universe. Launching objects such as a human-carrying rocket ship could be a popular means of space exploration. Due to the increasing amount of debris in space, launching these spacecraft may become unsafe in the future. When rocks in Earth's outer orbit collide with each other at high speeds, it creates many small fragments that are very harmful to each other in the spacecraft exiting Earth's atmosphere. Removing or decreasing amount of space debris would also be useful in the long term of space travel. Implementing or modifying programs for space travel to incorporate a means of disposing of the leftover spacecraft can greatly reduce the amount of space debris. If we continue on this unsustainable path to launch rockets into space without any way of disposing of them, eventually, man-made satellites will be at a higher risk to get hit by something. Satellites, telescopes, and space stations that may be to come in the future would be under constant threat from space debris moving at dangerous speeds. It would only be a matter of time before something important get hit by a stray part of an old rocket ship. Space debris can and will be highly detrimental to our progression in Earth and space sciences if we continue on this path of unsustainability.